Hi everyone, hope you are doing fine. So today again I am going to solve the another LeetCode contest. So yeah, let's see. So today I am going to solve this weekly contest 505. So yeah, so let's start with the contest. So let's see what is the first problem. Sum of compatible numbers in range. Yeah, you are given two integer n and k. A positive integer x is called compatible if it satisfies both of the following condition, like if the absolute difference between n and x is less than equal to k and n and x equal to 0. So return the sum of all the compatible integer x and denote the bitwise AND operator and the absolute difference, like yeah, absolute difference between I and j. You are given so what they are asking problem, like we have given some positive integer x, positive integer two integer like n and k, and a positive integer x is called compatible if these satisfy both the condition, like if the n minus x is less than equal to k and x is 0, like and is 0. So the first thing, like I think yeah, you can see the constraints are very small, like in this the n value n and k are up to 100. So we have to only check, like absolute difference less than equal to k. So like if we are choosing like k as 100, uh then we have to choose like, then in case we can choose only x up to like 100, like plus 100 and plus 100 and minus 100. So yeah, so it's quite simple. So let's write the code for this. So what we are going, we can simply going to try, like, can there be possibility of negative numbers? No, like we have to only check for the positive number. So yeah, so the number in the range are going to be, like in start value of the x is going to be a n minus k. Yeah, and start is going to be a max of 1 comma start, and int and is going to be a n plus k. So we can simply loop from I equal to start, I less than equal to end, and simply do I plus plus. And now we have to check two condition, like if the absolute, like you can see, like absolute difference is always going to be less than or equal to k. But we are now we are to only check this condition if uh, I and n equal to 0, it means that number is a compatible number and we have to add in our answer. Then we do answer plus equal to I. Initially our answer value is going to be a 0, and then we are going to be return 0. So let's try to run this code. So this is giving us a wrong answer. So let's see what is start and end value. We are getting start and end. So yeah, we are getting a start as 1, which is true, and as a 5 if I and n is equal to 0. So as this is a bitwise and, so we have to do. So why is it not giving us a, like, yeah, let's see what is and of I comma n, and also print I. What are uh, what is I doing? Yeah, you can see like I have simply write the 0 at there. So yeah, this is, I think this is going to be work. Yeah, this is working. So let's move to the next problem. Second problem is like a valid binary string with cost limit. So you are given two integer n and k, and the cost of a binary string s is defined as the sum of its all indices and zero basis such that s of I equal to 1. A binary string is considered valid if it does not contain two consecutive one character. Its cost is less than or equal to k. Return the list of all the valid binary strings of length n in any order. So yeah, this is interesting question. So yeah, so like in this case our n value is 12. So like the string size is going to be a n, and is going to be a 12 at most. So yeah, so let's say we are trying to build all the valid possible case, like so what are the valid possible case? Like its cost must be less than equal to k. And what is the value of k? Like k is also going to be a less than equal to n. Yeah, why k can be up to like if n is 12, 12 into 11 by 2. Why it is even possible, like because the it cost is 1. Oh, sorry. The cost of a binary string is defined as sum of all its indices I such that s of I equal to 1. Like if I is equal to 1, then it's, yeah. Uh, so it is a correct value, correct thing. So I think that we can simply use recursion in this recursion to generate all the possible combination, like because we have to print, so we have to generate that thing. So let's say in case of let's see example they has given n is 1 and a k is 1. N is 1, k is 1. N is 1 and also n is 3 and a k is 1. So like we have to generate three sides substring. So we can we have like every index we have two possible, like if we can place 1 or 0. If we place 1, for the next we have only one option, because we cannot place two consecutive characters. So at that for next we have to place 0. So now for the next one we have two options, like we can place either 1 here or 0, but we cannot place 1 because like in like if we place this index is 0, this is 1 and this is going to 2, so it is going to be a greater than k. So yeah, so it is not possible. And so let's say we try another thing, like if we place 0 at first place, then for second we have two options, like we can place 1 here or 0. Let's say if we place 0 and we will place 1. So now for here we can place only 0 because previous value is 1. So for this we have two options, 0 or 1. But the value of index is here is 2, like 0, 1 and 2, and the k is 1, so we cannot place 1 here, so it is going to be 0. So by doing this thing we have to generate all the possible combination. So yeah, I think if you know recursion, this is a pretty easy problem. So let's try to write the code for this thing. So yeah, you can see that first is 0 0 0 and another one is 1 0 0, because in this cost is 0, and in second case cost is 1, and in third case cost is 2, and in fourth case the cost is also uh 2. Yeah, but k cannot be greater than 1, so yeah, in that case we have to do this. So yeah, uh so let's define something like string of answer, string, a vector of a string. Then we have a simple function uh which is going to take firstly the index, like size of the in size, like how many characters we can like the size of the substring. And then we have something like a index and something like a preval, like a previous value. Yeah, and I think we need k also. So yeah, that's it, I think. So what is going to be the base case for, like if the like if the index is equal to n, like yeah, in that case it means that we have find our answer. So we can simply return and do answer dot pushback. Simply let's say we can also define a string t here also, so which is going to be maintain in which we are going to maintain our answer. So yeah, so that's it. And now what we have to check, we have to check whether we can add 1 or 0. So like if the previous value is already 1, then we have only one option, we can only add a 0. Yeah, we can only add 0. Previous value is going to become 0 and the k become k. Else we have now two option, uh, we can either add 0 or either 1. So if we are going to add 0, it is going to be a same thing, like and remain same, we move to another next index and the pre value remains 0 and the k remains same. So now if we are going to add 1, so we have to check firstly if the k is greater than or equal to index, we can only add 1. So in this case we are going to add 1. So is this previous value is going to become 1 and the k value become k minus index. So yeah, so in this case now we have to also maintain our answer na? So yeah, we are going to t dot pushback a 0 here, and then in while backtracking we are going to pop this thing, and again push back a 0, t dot pop back. So similarly we have to here also t dot push back 0, and we have to do t dot pop back. So yeah, I think it is done. So yeah, so now simply, or we can also add a base case like, so no need for that base case like if the value of k become less than 0, so we are handling here also, so no need for that. So we are going to simply return answer and this call this function. So firstly it is taking the n and then it taking index. So initial index is going to 0 and pre-value is also going to be 0 and case, yeah. So let's see if it works or not. We are getting all zeros. We are getting correct answer but getting all 0. So yeah, here we are adding 1, so we have to add 1. So yeah, I think it should work. So let's try to run this. So yeah, it is working, you can see. So now let's move to the third problem. Maximum sum of m non-overlapping subarray 1. So you are given an integer array nums of length n and a 3 integer m, l and r, and your task is to select at least one and at most m non-overlapping subarray from the nums. At least one and at most m. So each selected subarray has a length between L to R inclusive, and the total sum of all the selected subarray is maximized. Return the maximum total sum you can achieve. So yeah. So the problem is uh, simple. Like you can see, like a problem is pretty easy to understand what we have to do in this. So let's see. Like in this, we have something like given three integers like m, l, and r, and a array, and we have to select at least one. We have to select at least one subarray, and we can select at most m subarray, and the subarray length should be in the range from L to R, and the total sum of all the subarray is maximized. So yeah, we have to maximize the sum by taking the at least one and at most m subarray. So let's see in the in this example, let's L is 1 and R is 3. So like in this case, if we take first subarray 1 and 4 and then take 2, it is going to give a value of 7. So yeah, which is maximum. Similarly in second case, we can choose max of 2 subarray and L and R is 2. So yeah, if we take this 2 size subarray and this one size subarray, and the in this case answer is going to be 8. So yeah, the problem statement is clear. So let's see how we can approach this problem. So the constraints are up to 1,000. So yeah, we can do something like n square thing in this. So let's think about that. How we can do. So we have some array given like, and we have to take like L and R. We can take sub array of this length in between L to R. So yeah, so if this part is going to give us the positive sum, we can take this. If this is going to be positive, we can take it. Again, like some negative, we have some negative value here, and then we have to take some positive. But there may be possibility that if in this case if we have to only choose two, we are taking this subarray, this array, and these three, and we can take only two of that. Let's say if we take these two, then we are. But if we take this part like something like that, this is this is going to give a maximum answer, like how we are going to handle that case, like so what we can do. So let me think how we can solve this. So if we take all this subarray, like if we make all this subarray of that length also, like from one we start. So what I'm thinking, like we can try to make all the possible like subarray, like one like this one. Then we are going to, like if we have something like 1 0 3 4 2 1 6, and we can take only length of 2 to 3. Yeah, 2 to 3, and the k is maximum, like maximum of 2. So I am thinking of, let's say we can make all the possible subarray, like this one, which is going to start at 0 0, and then another one is going to be a start at 0 1, then another is going to be start at 0 2, then 0 3, 0 4. Yeah, like pretty like this 6. So yeah, we are going to make something like that, like 0 4 0 5, and similarly 0 5 and 0 6, and we can simply calculate this sum, like and also we can store like sum here, like what is the sum, or we can simply do a prefix, like a prefix array, like do prefix sum of this array, and then from that we can easily calculate the any part prefix, like any subarray prefix sum in a constant time. So by doing this, then I can again start from 0 1, then from 1 to 1, then 1 to 2, then 1 to 3, then 1 to 4, like like this up to 6. And then similarly for this, like I am thinking like we can do for like something like this for every index, like from then from 2 to 1 to up to 2 to 6, so on to from 6 6. So by doing this, after that we are going to, like we can also store like something like sum in here also, and we can sort on basis on the sum, like if we have something like the array will look something like it's going to be 2D array, like 0 comma 1, like yeah. So like maximum at maximum, and like it is a maximum, and like we end at 1, and our sum is 9. So let's say we can simply maintain an array, like we are going to maintain array, like simply at 1 the sum is going to be a 9. Then let's say we have something, because we are going to sort the array by a maximum value. Then again we have something like 8 comma 0 2. So if we have something like this, I think yeah, it is not possible, but let's assume it is possible. Yeah, it is possible because if the second value is negative. So yeah, if the 0 to 2 value is 8. So but we cannot add this value to our previous thing. Uh, like uh like 0, 1, 2, 3, 4, 4, 5, 6, 7. So yeah, so up to 2 the value is like in case of 2 the value is max value is 8. So let's say again we see something like 0 like 4 comma 2 comma 5. So now we see 4 we see 4 value, so 4 sum, and it started at 2 and at 5. So like we can take like a maximum sum we can get from previous, like something like that we can do. Like in this case, like at 1 it was 9 value. So yeah, like we can also maintain something like a k, like how many number we have choose previously, because the previous value are always going to be a greater than. So yeah, so if in any case, like let's say in this case for 2 value start at 2 and at 5, it is going to be a 4. 4, like for 5 it is going to be a 4, plus like if we can add this 9 to our answer, it is going to be a 13 at this 5. So yeah, it is going to be a maximum. Let's say this is our example. In that case it is going to be a maximum. Let's say again we have something like a 2 comma uh yeah, value is 2 and it's a 2 comma uh, sorry, it start at 6 and at 8. So in this case the first value is like we can't take like 13 now here. So in this case we have to maintain for every k also, like how many k we have already choose, or we can say like n minus 1 k. So yeah, I think is it even is it even true condition, like because like if as the values are in uh, descending order, so I think like we will get the best answer first. So like if there is a some combination, so I think for this 5 we may get better answer, or it may be not possible, like there may be case like at 6 and 8 there may be a value of 12, and in future all so but it then it will be not in a sorted order. So yeah, so let's see, write the code for this. Let's see if it will work or not. So yeah, use using LL equal to long and firstly we are going to generate all the possible sub array I plus plus for loop in j equal to 0, j less than, like we don't need to generate all the possible because we have to generate only if the l in the range like sub array size of l and r. So we can also make a size equal to 0 and I equal to j equal to 0, and we can do up to n j plus plus, and yeah, size plus plus we can do, and if the size is greater than equal to or greater than r we have to break, and we also need some in sum equal to 0, and this j is going to be from I, and we have to declare a vector of vector array, and if the uh, size is greater than equal to L and size less than equal to R, then we have to push back simply yeah, t dot push back. We can simply push sum, and we also do sum plus equal to v of j. So yeah, we have to add something like sum comma, like start from, it is going to be start from I and end at j. This is even make sense of doing this on. So what I am trying to do is like how we can then check like the array will be in a completely unsorted array. There may be possibility like this 6 comma 8 will be like this range will be calculated for 6 comma 8, and then after that we have something like 2 comma 3 here, which has value 4 and this has value 10. So yeah, in that case we will never add this 2 to our answer. So instead of doing like this, can we do something like we can sort at the end, like sort by end time. Sort by end time like 2 3 6 8, like then we have something like 8 9 10 11 13 15. So yeah, in that case like we can check from previous value, like if we want the maximum that and that 9, that and that start at 8 and at 9, and we can take like as much as want, like maximum from previous value. But again, do we have to do loop in that case? Can we do something better like we can maintain top k for every value like that? So yeah, we I think we can maintain because the value is only 1000 up to 1000. So I think we can also do that thing also. So what I am thinking like I think yeah, this approach will work. So I am thinking like what I will do, like I will generate some like I have something like this value, and I will sort according to the end time, like where the array is ending, and then I will try to make like I am checking at every end, like for every sub array I assuming that this is my the last point, so this is my end point. So I am taking this like sub array, and now you can give me some better like some, if possible you can give me some sub array whose sum is positive, and and you can take up to k minus 1 sub array, k minus 1 sub array from this part. And then again we check for this, if we have something like we are at 10 comma 11, then again I am taking this, and you can give me better k minus 1 if possible, top k minus 1. So yeah, let's see. So instead of then, if we are going to sort by the and, so we can make something like j comma I comma start. So it is going to be so we don't need comparator to sorting for sorting. So we can sort this simply t dot beacon comma t dot end, and then less than n I plus plus. But like because this calculation is also going to be a very like complex and also be time consuming, like it is going always so take to be going the big of n time. So already we are generating some subarray, and subarray may go up to like n square. Yeah, we are generating some n square array, and then on again on that we are going n square. So yeah, I think it is going to be gift TLE. So yeah, let's write and then see how we can optimize. So how we are going to get the top k? So I am thinking of maintaining some priority queue, or we can say, yeah, yeah, we can simply maintain a priority queue and do like uh, priority queue, I think is good here in comma, or we can simply maintain LL because the sum is going to be a very high LL because we need mean priority queue. So yeah, so we have to do something like this and maintain this priority queue, and then from int I equal to 0, I less than oh sorry, int j equal to 0 and j less than equal to I minus 1 j plus plus. uh I need like what is going to be start like it is going to be a t dot size. So like my start value is going to be a like start index, we can say start index is going to be a t of I comma 1. Yeah, int and index is going to be t of I comma 0, and int like sum is going to be a t of I comma 0, I say. I think that's it. So yeah, after that we can simply check if the value is we are going to take this sum, and now we have option for k minus 1. We can take some k minus 1 thing. Sorry, k, yeah, we can take some m minus 1. So we have to maintain a priority queue, and we can check if like t of I comma 1 is going to be the and index. If this and index of that subarray is going to be a less than, because the subarray cannot be overlapping now. So it must be a less than the start index. If it is true, then we can do something like pq dot push pq dot push back what is going we have to push back t of I comma 2, and also we can add this to our sum also, like we can maintain like total sum variable. Total sum is going to be a initially 0, and we can say total sum plus equal to t of I comma 2. And yeah, and we can check like if the pq dot size is greater than like if yeah, if priority q dot size is greater than equal to greater than or equal to k, greater than or equal to k, it means that we have to pop this value. So yeah, in top equal to pq dot top, and total sum minus equal to top, and we do pq dot pop. So at the last what we can do, we can simply add like total sum plus equal to sum, and answer equals to max of answer comma total sum. So yeah, we have to simply return answer here, and let me declare answer here also. LL answer equal to 0, and yeah, so as we are doing total, we can declare it as LL. So let's see if it is working or not. Int n equal to v dot size, and we also need to change it to v, and I am using k everywhere instead of m, so let me write k here. So it is going to be break. It is going to be a sum, not start. Yeah. So I am defining it. Let me, I think int is going to be a good here. pq dot push. So yeah, let's see if it is working or not. Getting wrong for first second. Yeah, I think for everything we are getting every input we are getting wrong answer. So let's see. So let me check if I am generating a correct sub array or not. Ji, like if the size rvm also increasing size every time size is greater than or than break, else sum plus equal to v of j. Yeah, if size is greater than equal to l, uh, and size is less than equal to r, then it's correct that we are going to push back t. So let's print this t also, for auto it comma t, and for auto a t. Let's see what we get. So we are getting something like 0 0. And we can also check something like if the value of that t of I comma 2 is, sorry, and it is going to be a t of j, or it is going to be t of I only. Yeah, and we also check like if t of j comma 2 is greater than equal to 0, because if it is values are negative, then there is no need. In that case we can take only one value, like in that case sum will be always going to give us an answer. So let's see now. Again getting 3. Like we can simply get 4 from here only. Like if we can take this, let me print total sum, total sum, total sum, comma sum. So why are not, we not getting like this 0 0 4 in this case? So let me simply comment this thing and check. I think now it should work, but again it is not working. Like it is giving us 5 from this, but it also has to take 2 from that value also. if the and index of and index of previous value must be less than the start index of the current value current yeah subarray, and also that t of j comma 2, that some value of that subarray must be greater than 0. Then why it is not working? So after that array will look something like this, yeah, in this 3 3 it must take like this 1 comma 0 value, I think, but it take only sum of 2. Why? How total sum need to be 0. So why 0 1 2 3 4 5 6 7 8 equal to 8. Let me check for 8. Yeah, total sum is 7, but why when I'm starting from 0 not? Oh, so yeah, so we also have to make this priority queue empty for everything, every loop like we are doing internally also. 7 8 6 minus 1, 6 minus 1. Yeah, I think answer is going to be a long mean, I think. Yeah, I think it is working now. So let's try to submit this. I think yeah, it is going to be a give us a TLE. So let's see how we can optimize this thing. So yeah, so instead of giving TLE, it is giving us, how is it even possible? Like sum is going to be a, how sum of 56 is even possible? So I think I miss one condition, we are taking like all subarray, but there may be possibility like these subarray may be overlapped, something like this. So we can't take like every subarray, like we have to do something like some pre-computation to check like this. So let's take like example it as a subarray, simply subarray problem, like we have something like 1 2 3 4 5 6 7 8 9. So yeah, I think let's assume these are overlapping. 1 2 and 3 are overlapping. So how we can maintain this thing, like these should not be overlapped. If we have like if we currently take like this thing is correct, we are checking for everything, but we have to do some when we are checking like this case there may possibility we already have chosen something, but and again we choose something that are that may overlap. So yeah, in this example, firstly we choose something in case of 3 3 comma minus 5, like 3 you can see yeah, 2 comma 2, it give us value of 24, and 2 like start at 1 and end at 2, it gives us value of 28. And we are taking this and again start at 0 and end at 2 and has value of 4. We also take this, but you can see like this our value are overlapped in itself. So yeah, so we can't take this blindly, so we have to do something like, so we have to track this thing how we can do. So let me think how we can do this. How can we do this? Best ending at this position. So if we are like now they are sorted by the end thing. So let's say it is 0 1 0 2 1 2 1 3 1 4 2 4 3 4. So for this, if we are calculating answer, we have to choose some best thing from here, ending at this position. Like yeah, not there, but it is 2 2, so it will match. So let's say 1 comma 4. So it take like what is maximum like what is the best answer if we take 1 3, and we can take up to k minus 1 value. So if we are going to take 1 3, then we can't take 1 2. Then we have to take previous than 1, like nothing. There is nothing we can take if we take 1 3. And similarly, if we take 1 2, let's say it is from starting from 2 only. So then like it's and start at 2 and end at 3. Then we can take this 1 0 1 also like this 2. So we also have to do something like track this. But if we are going to do this, like this is going to become a recursion and time complexity is going to be very high. So it's something like increasing subarray, some problem like that, that kind of approach. Like, but how we can do something like track k from this position. So if we are taking like from 0 1, let's say we are getting value as 2. Then from 0 to, let's say it is value is 4. Then 1 2 value is 3. And then from 2 3, and let's say there is one more value like 1 1, and its value is 5. So if we are going to take 2 3, we have two option, and let's say k is only 2. So if we are going to take this, we can also only take one of these value, like either we can take this or this. And then this is going to be same for this also, previous value also. So yeah, I think we can do like this. So if 0 1, like if we have 2 comma 3, 2 start subarray starting at 2 and ending at 3, then we can check like better value or like some positive value we can get from previous subarray. So from 1 1 we are getting 5, and from 0 1 we are getting 2. So it is always benefit to take the 5 1. And also in this case, let's say k is 3, so we can also add second one also. So but for 5 like 1 1, there are only one value, like you can see like 5 is the only value. So if 5 is the only value, then yeah. So in this case, it is going to be a 2 comma 3 value has, let's say assume it has 8, then it's going to be a 8, like if we are making a priority queue, let's maximum value at top 8 comma 5 is going to be like this. And then again we have 1 to 4, let's assume it has 10. So now we have to take something better, that and that one, there is nothing, so we can simply ignore this. Like for, but for 2 4, but is the best answer we can get from here. Like 2 4, let's assume it has value of 3, but from 2 4 we can take 1 1 or 1 0 1, because like we can take any of the answer from this previous value. But if it has already k, let's say k, then we have to do k minus, like only take the top k values. But how it is going to become a k? Yeah, let's say 2 4. Now for 2 4 we have something like 2 4, 2 4 value is 3, and then we have something like 1 comma 1 that has a value of 5, so it is going 3 comma 5. Now we have 3 comma 4. So yeah, let's see. Now 3 comma 4, we can sum of 10, let's say, and we have to take two value from previous. So firstly we can take something like let's say we are going to take 2 3 2 4. So if we are going to take 2 4, what k we can get? Like if we are going to take k minus 1 value, so it's going to be a this 3 comma 5, like 5 plus 3, like going to be 8. But if we take 1 comma 4, we are getting 10. But if we taking this 2 comma 3, we are getting 8 plus 5, which is going to be a better. But we have to check again for everything, and in that everything also we have to maintain top k, because we have to remove that from first value. Like if like in this case it already has like a 3 comma 5, or assume like k is 2 only, so we have to take only one value from here, so we have to remove the minimum value, and that minimum value, yeah. So like if k is going to be like 100, then we have something like let's assume it has something like 100 values previously also, we are taking that 100. And for this yeah, now if we are taking this value, then we can only choose 99 from this, because one is we have to going to take from this, so we have to remove that minimum value from that. So for everything we have to make a set, like it is going to be like n cross n. How we can do, like if we are making PQ for this, and total subarray can be up to, like if it is from 1 to n, then it is going to be n square, like 1000 into 1000 subarray, it's going to be 10 raised to power 6. And then for again we have to check back, like a check in previous direction, and for that also it going to take a big O of n, like for 10 raised to power 6 it is going to take big of n again, like a n square loop. And then we also have to maintain a priority queue for everything. I think this approach will not work. We have to, So let's see. Let's give a half an hour more to this problem and see if I was able to solve this or not. If I am trying to generate all the possible thing like a 4152, like I'm like start like the size of subarray, index of subarray, size index. Index is going to be 100, 1000. Size is also can go up to 1000 in worst case when the R is 1000. In that case, K can be a very less. Like if it is going to be 1000, then K is going to be a less. It is not possible. Like so, I am thinking of by doing it recursively and then make all the subarray. Like if I am taking this and then taking this or like all the possible. But in that case, I am thinking like if after how I can optimize the DP state. Like DP state, like it is going to be index. Firstly, index will be going to be changed and the size of this array. It is also going to be n cube. Like index is from 1 to 1000 and similarly the size is also from 1 to can be up to 1000 and similarly the K is also going to be a something like 1000 we can say. Yeah, M can also up to 1000. Can I do this thing effectively? So index can be up to like, can we do some optimization here in this because we have to move index forward all this. It is not possible to optimize this thing. Can size and can be treated as something like if size is going to 100 then k can't be more than can say 999 or 900. if I am going to take L5. Mm, so how we can do this? So let's see what's the next problem. So the next problem is also same, but it has constraint up to 10 raised to power 5. So I think yeah, we can solve by something like this approach also. Because in case of 10 raised to power 5, we also can't do something like this, like a DP, like recursively and stored like DP. If it because in this case it is going to be n square also will not work. Let's see just if this problem is exactly same. Yeah, it is exactly same. So I think for today, two question is more than enough, and we'll try to solve it later. Yeah. If some let's again give a one try. Some sub barrier here and something like this. Start and we have something like start and end sub array start and end index, and we are going to sort on the basis of, and we can say or start. If we are going to sort on the basis of and, let's say yeah, we are going to sort on the basis of and now to choose the best k minus 1 from the previous, and like it's something like 9, start at 9 and something like 12. So I have to choose something like a 3, we can say k equal to 3, and so it means that I have to choose 2. I can choose up to 2, like I can choose up to 2 k sub array from previous value from here that are also not overlapped. Like the main problem is that thing, like how we can check if it is if I am like, so it's if its sum is 10, I can maintain two sum, like sum one like top k minus 1 sum including itself, and a overall k sum including if it like if it is less than k minus 1, then I have to need only one sum. If it is equal to k, then I have to choose something like, and then after that, like as the value are up to from like 1 to 1000, so I can maintain like something like this, and do prefix also, like maintain, like if it is value it's present at 12, 13, 4, 21, 16, like this I going to like 0, 1, 2, 3, 4, 5, 6. So after that, like if I am going to update every value at this index, if we are going like but the main problem is like how we can even get like this answer if efficiently from this also, because it is also not sorted, but it has only 10 raised to power 3, but again it's 10 raised to power 6, then it again 10 raised to power, it become 10 raised to power 9. So yeah, I am not uh, getting, like I think I have solved similar problem like in which I have to do something like this, but I'm not getting how I solve that problem. Like not similar exactly, but I think the concept about like 40-50% same, I think, but now I am not getting that thing. Like if we are at this position and we get 8 as answer, and this like it end at 12 and start at 9, so 12 become like this 12 become 8, but how I can get, like there may be possibility like some start at something like let's assume some end at 4 and get 16 value. So now I have something like here like 13 to 18, and now I get I want the maximum possible from previously 13, like let's say it's a 12, so I want the maximum answer I can from this. So yeah, I think it can be simply done by simply taking the prefix, like what is the max, like 17 here, 13 here, 14 here, 21 here, 16 here, and sorry, 21, 21 and 21, like here is going to be 21. So in that case, I have to sort basis on the base of S, not E, because if I am going to, let's see, if is it, yeah, we can sort basis of E only, because first and is going to be a, but there may be possibility like and also and can be a very can and be a very big. Yeah, I can say like we can loop every n also. Like if something is ending at 0, starting at 0 and at 5, and some another thing ending at 9 and like starting at 9 and at 10. So in like there is a difference like 5 value only. So like as it is going to a very small like up to 1000, we can iterate this as well to make this prefix. So let me firstly again think once again about this. How can we do? So firstly, yeah, this thing is going to remain same, but while tracking some like if we have something like 0 to 1, 2 to 3, 3 to 4. So this is going to be a like let's say it is 3, it's 4, it's 5, and now this 3. Now as these are not overlapped and the k is 3 in this case, and as this is not overlapped with this, so we can take the k sum from the previous thing. What is the top k? Top k is like 3. So yeah, so this is like this this is going to be for a k minus 1 for everything. Like we are only taking going to take a k minus 1. Like if k is going to be a 3, then we are taking only two value, because one value is going to be the current subarray we are for we are checking. So for 1 it is going to be a 3. So then we move to 2 comma 3. So we check is there is any value like yeah, this is 0 1 2. So for 0 it is going to be a 0, for 1 it is going to be a 3. So let's say for 2 comma 3 it's going to be a 4. So yeah, we can see 2 comma 3 it's a 4. So we can check what is the k minus 1 value. Like it's a 1, so we have to maintain also like something like this thing. What is the k of that thing? So again the same problem arise, like if if it has k minus 1, we have chosen like k minus 1 subarray from here. In this case it's only 1. So let's say now in case of this, so it become 4 plus 3 like 7 comma 2. So we have choose 2. So let's say we have something like 4 comma 5 here also, and for case of 3 comma 4 we have something like 5, and we can choose yeah, this thing also. So it becomes 3 plus 5, 8 comma 2 also. So now for 4 comma 5 we can take two values. So we can take 2 comma 3. Yeah. So if we take 2 comma 3, it becomes something like 4. Let's say it also has 5 value. Uh, 4 plus 5, it is going to be a 9 comma 3. But it is going to be 3. But we need a k minus 1 for here. Because we can't take like because it has two value already. So yeah, so yeah, we can take like we can take these two values, but now for this like 4 5, we have to take one less value, because if we are going to take the k minus 1 for this thing, then it should be I think it should be like k minus 2, because like if we take this k minus 2 from here and 1 from here, it become k minus 1. But if we took like take k minus 1 from this value and then take 1, it become k already. So we can't take like like 9 comma 3 here, because we are taking k minus this array is for maximum value we can get by taking the k minus 1. So yeah, so then, like, how can I optimally again take the k minus 1 from this? Can this be only for these two case only? Yeah, because like if we have something like k equal to 8 and we have something like 7 value here and 1 we are taking, so I think we have to maintain two k's, like one is the k minus 1 and another is the k minus 2. I think if we maintain these things, uh we are good to go, because in case like in case of 3, like if we have maintained something like a top k minus 1 for it also. So like for this we maintain like sum is the sum was 7 for this, and if we take only so it's k minus 2 become k minus 2 become 1. Here it was 2, here it become 1. So for 1 we can only take 1, like 2 comma 3 it is going to be a 4 value. But in case of what happen in case if k equal to 2, so we can only take one previous subarray. Yeah, I think, let me think, write the code for this also. Yeah, the most of the things are going to be the same. Mm, but we have to do maintain in dp1, so yeah, size plus 1 vector int dp2 of size plus 1, so it's going to be a size and we can define size as p dot size. So yeah, as we are sorting by and time. So we have to take care of k minus 1 and a k minus 2. But again, the problem is like if the what is the value of the count is 3 comma, we can maintain it as a pair of int comma int, pair of int comma int. Yeah, int like I am checking only the previous value, like We can declare it as a vector of vector. So it's all going to be as initially 0, and then yeah, what is the sum? Int max. Yeah, I am maintaining total sum. Total sum equal to max of total sum, comma, dpy of j, comma, 0. I am not getting this problem, so yeah, so that's it for the today. So I will try to solve it later and will share by tomorrow, like if I was able to solve this or not. So yeah, so that's it for today. So let's see the daily challenge problem of LeetCode and try to solve that. So let's see if it is your same. So yeah, I have already solved this problem. So the problem is number of substring containing all three character. So you are given a string as consisting only of character ABC, and we have to return the number of substrings containing at least one occurrence of all three. Return the number of substring containing at least one occurrence of all three characters A, B, C. So yeah, so this problem is like the first thing, like we can make like we have to make return the number of substrings containing at least one occurrence of all these character like A, B, C. So in this problem, what we have given something like ABC, AB, like can it be a different value also? Yeah, as can consist of only A, B, and C. Something like we can say A, B, C, A, B, C, something like this. And we have to return the number of subarray containing A, B, C. Like first subarray is like this subarray contain A, B, C. So like if we get first subarray, after that all the subarray are going to be containing A, B, C. So we can simply add one this like this like this thing. So yeah, so it's a quite simple, like we have to find the first subarray, like in this case ABC, ABC, and ABC. If we get like we get first subarray, after that we can check like what is the size of this subarray. The size of subarray like total string is 9. So and the we are at index 0, 1, 2. So yeah, so the size is like n minus 2, and we like what is the n minus 2? N minus 2 is going to be a 7. So there are going to be a 7 subarray. You can see like one is this, and another is like if we take ABCA and ABCB, then this total are going to be a 7. So we get 7. So again after that we are going to remove the first character, like the starting character of this array. And now then again check if the ABC is not possible or not, but in most of the case it will be not like it will not be possible. Then we again move this window, like we are moving this window forward. Now we check ABC. Now you can see again ABC is present in our substring. So yeah, So again we can add something like what is this, we are at index 3, so 9 minus 2 is 6, so 7 plus 6. Then again we remove this b, and now we remove this window forward. Then c, now we have something like cab, again it has like all three characters. Then we add something like 5, and this will continue. So yeah, so this is so that's for this problem. So let's solve this. So initially let n be the size of the string, and after that we are going to simply, instead of doing this, we are going to take a low as 0 and a high as 0, and int a count is going to be 0, b is going to be 0, c is going to be 0. And we do this loop until high is less than n. And when we check like if s of high is going to be equal to uh, a, then we do a plus plus. Else if s of high equal to b, then we are going to do b plus plus. And in else case we are going to do c plus plus. So yeah, we check if this like if is a is greater than equal to 0, and b is greater than equal to 0, and also c is greater than, oh sorry, greater than 0. Oh yeah, we can say greater than equal to 1. So if all the values are greater than equal to 1, then we can simply add answer plus equal to high minus like n minus high. So this is what yeah, this is same thing like we, if we are at this like at this index, and we are making going to make n minus high sub like n minus I sub array. So after doing this, we are going to move the low like yeah, we are going to do low plus plus. But before doing low plus plus, we have to make the count of the that low like character minus 1. So we check if s of low equal to a, we do a minus minus, a minus minus. Else if s of yeah, low equal to b, then we are going to b minus minus, and else we are going to do c minus minus. And after that we are going to return our answer. So let's see. So it is giving us error, so we have not declared answer variable. So we have like every like whenever we track something like this index, we have to move forward also. So for that we are doing this. So instead of doing this like in this case you can see like firstly we don't get like abc make at this point, but after that we are removing from backward, and again we are getting answer. So for that case, instead of doing if here, we are doing while. Like again, you can check if it is possible for that answer or not. So let's try to submit this. So yeah, you can see it is working. So yeah, so that's it for today. So now I will try to like today I study about a little bit about Java, about like I study about inheritance, like all the four pillars of the oops, and also wrapper classes and primitive data type. So yeah, so now I will study about system design. So I will also share what I do in system design today. So yeah, thanks for watching the video.